At first glance, it was the perfect twin. Nearly identical in size, mass, and composition, Earth and Venus were born from the same cosmic cloud over 4 billion years ago. Venus formed near the inner edge of the region where liquid water might once have been possible. Some climate models suggest that ancient Venus may have remained relatively temperate, with shallow oceans, for billions of years. So what broke the symmetry? How did a world so structurally similar to Earth turn into the most hostile environment in the solar system? The runaway greenhouse effect. As the young sun gradually grew brighter and hotter, Venus reached a critical tipping point. The rising temperatures began evaporating its liquid oceans. On Earth, oceans act as massive carbon sinks, trapping carbon dioxide inside rock and sediment. But on Venus, the evaporating water released immense amounts of water vapor into the atmosphere. Water vapor is a powerful greenhouse gas. As it trapped more heat, the surface temperature surged, driving even faster evaporation. This self-reinforcing loop, the runaway greenhouse effect, eventually drove Venus toward a world where stable liquid water could no longer survive. UV radiation from the sun then split atmospheric water molecules into hydrogen and oxygen, allowing the lightweight hydrogen to bleed off into interstellar space forever. The Inferno Below. As Venus lost its water, its interior and surface evolved very differently from Earth. Without Earth-like plate tectonics to efficiently recycle its crust, heat continued building and escaping through a very different kind of geological system, one dominated by volcanism. Vast amounts of carbon dioxide and sulfur dioxide were released into the atmosphere, sealing the planet's fate. Today, the surface of Venus is a pressure cooker. The atmospheric pressure at ground level is 90 times greater than Earth's, equivalent to being nearly a kilometer under Earth's ocean. Temperatures hover around 465 degrees Celsius, hot enough to melt lead. Above this scorching wasteland float thick clouds of sulfuric acid droplets, completely obscuring the surface from human eyes. Metal-melting hell and the landers that survived. To truly understand how extreme Venus is, humanity had to build machines that could survive a metal-melting hell. During the 1970s and 80s, the Soviet Venera missions sent a series of rugged landers directly to the surface. Constructed like heavy deep-sea submersibles, these probes were built to withstand the crushing atmosphere and searing heat. Most lasted only an hour or two before the pressure and thermal loads destroyed their electronics. Yet, in those precious minutes, they captured the first, and so far only, panoramics from the surface of Venus, revealing a desolate, flat basalt wilderness bathed in eerie, scattered sunlight. They proved that operating on the Venusian surface is among the toughest engineering challenges in space exploration. Clues in the clouds and Phosphine mystery. Yet, high above this molten nightmare, conditions change dramatically. Around 50 kilometers up in the cloud deck, temperatures and pressures drop to levels strikingly similar to Earth. This niche has led some astrobiologists to wonder, could life have adapted and migrated upward as the surface burned? In recent years, spectroscopic detections of trace gases like phosphine sparked fierce debate. While non-biological chemical processes remain the leading explanation, the detection remains controversial, and no evidence of life has been found. But the controversy made one thing clear. Venus still has secrets hidden in its clouds. The next frontier of exploration. To solve the riddle of Earth's lost twin, a new fleet of missions is being prepared to breach the veil. NASA's Veritas mission is designed to map Venus's surface in unprecedented detail to search for active volcanism and possible evidence of ancient oceans and shorelines. Meanwhile, the Da Vinci mission is designed to send a probe plunging through the atmosphere, measuring gases frame by frame before hitting the ground. By analyzing noble gas isotopes and surface geology, these missions aim to tell us precisely when Venus lost its water and whether it was once truly habitable. A mirror to Earth's future. Understanding Venus is more than an exercise in planetary history. It is a critical lesson in planetary evolution. It reveals how thin the line is between a paradise and a wasteland. As we discover thousands of exoplanets across the galaxy, Venus reminds us that orbit and size alone do not guarantee life. Do you think Venus once hosted primitive life before its oceans disappeared? Let me know in the comments. And subscribe for more deep space investigations.